Imagine a number that the human brain is incapable of processing. It's a number so large we use a symbol to represent it. That number is infinity. Infinity can be defined as a number greater than any assignable quantity or countable number. Well, that seems simple enough, it gets really confusing really quick. It doesn't behave like normal numbers. A set of all the even numbers equals infinity, but so does a set of every number, meaning half of all countably infinite numbers still equals infinity. An example of the use of infinity is an asymptote, which is a line that continually approaches a given curve but does not meet it at any finite distance. Asymptotes are a property of a rational function. An example of this is f of x equals 1 over x. This is a rational function where the asymptote is at 0. As f of x gets larger, x gets closer and closer to 0 without reaching it. One way we model this is by using the infinity symbol. Infinity can be seen in many places in mathematics. When you divide 2 by 3, you get 0.66666, repeating. This is an uncountable infinity, where your number is increasing to an infinite degree, but it never reaches 1. Infinity doesn't abide by normal rules of math. You can't add infinity like a normal number. Infinity plus 1 still equals infinity. Here's why. The numbers we use to describe how many of something is called cardinal numbers. An infinite set of cardinal numbers is called Aleph null. If you have two sets of Aleph null, A Aleph null and B Aleph null plus 1, you can create a bijection and pair each number from each set to each other. Therefore, both sets must have the same size, meaning infinity plus 1 equals infinity. While it appears you can't count past infinity using this logic, it is possible using some confusing mathematical concepts like ordinal numbers. Ordinal numbers are represented with the lowercase Greek letter omega. Ordinal numbers are something that tells you what position in a set something is in. This allows us to count past infinity. Omega is defined as something that comes after all natural numbers. In theory, this means omega plus 1 is more than infinity. There's a common paradox called the hotel paradox. There exists a hotel with an infinite number of rooms. One night, all the rooms are full. A man asks the manager for a room. The clever sausage of a manager asks the guest in room 1 to move to room 2, and so on and so forth. All of a sudden, an infinitely large bus with an infinitely large number of guests arrives. The manager moves the person in room 1 to room 2, and the person in room 3 to room 6, and so on until all the odd numbered rooms are empty. He then moves all the guests into the infinitely large number of odd rooms. The manager sits down after doing this for an infinite amount of time. When he looks outside to see an infinite number of buses, each filled with an infinite number of guests, but he has an idea. He goes to the counter and presses a button. Then boom! The hotel explodes. No. The manager remembers that there's an infinite number of prime numbers. So he moves every person to the room that is 2, the first prime number, to the power of their current room number. And he places everybody from the first bus into the newly freed rooms. The manager then does this for every bus using the next prime number. He takes Infinity has many forms: countable infinities, uncountable infinities, numbers that go past infinity, Aleph null, the infinities that exist within an asymptote. Infinity is vast and incomprehensible, but there are some concepts of infinity which you can learn.